Hi guys, today we're doing lesson 1.3 Rates of Change. Many real-life examples involve interdependent quantities. One of which is the dependent variable, which represents the quantities that are dependent on the independent variable. The rate of change is defined of how rapidly the dependent variable changes when there is a change in independent variable. The average velocity equals change in position over change in time, which is denoted by delta S over delta T. Now let's take a look at example 1 from learning resources. A pebble is dropped from a cliff 70 meters high. After t seconds, the pebble is s meters above the ground, where s of t equals to 70 minus 4t squared, where t is in between 0 and 4. Calculate the average velocity of the pebble between the times t equals to 1 second and t equals to 3 seconds. Before we list out any equation, we have to find out when t is equal to 1 second, how high is the pebble away from the ground, above the ground? So what we do is we plug t equals to 1 second back into our original equation of s of t equals 70 minus 4t squared. That will be 70 minus 4, which is 66. So at time equals to 1 second, the pebble is 66 meters away from the ground. At time equals to 3 seconds, we do the same thing. We plug t equals to 3 back into our original equation, and that will give us 34 meters above the ground. Average velocity, as we mentioned in the previous slide, is the change in position over change in time. That will be s of 3 minus s of 1 divided by 3 minus 1. That would be 34 minus 66 over 2, which is negative 16 meters per second. Therefore, the average velocity in this 2-second interval is negative 16 meters per second. Now calculate the average velocity of the pebble between the time t equals to 1 second and t equals to 1.5 second. So once again, we have to find out what t equals to 1.5 second is in terms of height above the ground. So we plug t equals to 1.5 back into our original equation. That will give us 61. We already know that t equals to 1 second is equal to 66 meters above the ground. So we plug it into the equation of average velocity, which will give us s of 1.5 minus s of 1 divided by 1.5 minus 1. And that will give us negative 10 meters per second. So the average velocity in the 0.5 second interval is negative 10 meters per second. The instantaneous velocity is the velocity of an object with position function st at time t equals to a. And the instantaneous velocity equals to the limit as delta t approaches 0 of delta s over delta t, which is the same thing as limit as h approaches 0 of s of a plus h minus s of a over h. To find the average rate of change, we use this equation, delta y over delta x equals to f of a plus h minus f of a divided by h. This is called the average rate of change in y with respect to x over the interval from x equals to a equals to a plus h. Instantaneous rate of change in y equals to f of x with respect to x when x is equal to a is limit as delta x approaches 0 of delta y over delta x, which is the same thing as limit of h goes to 0 of f of a plus h minus f of a divided by h, provided that the limit exists. And that's the end of this lecture. Thank you guys for watching. Remember to do your assignment as well as upload them for your teacher to mark. And I'll see you guys next time.